Hi everyone, I'm Gilchan. Today I'm going to be presenting the phishing email detection using Ontology. First, I'm going to talk about briefly what phishing is and the purpose of this research. Phishing is a cyber attack that attackers deceive users to obtain their confidential information, mostly for financial gain, or sometimes compromising the organization's internal networks. Phishing can be performed through various communication channels, and mostly phishers use email as an initial means of phishing attacks. Phishing was first reported in 1990s, and since then phishing is still on the rise, and its damage becomes devastating. To fight phishing attacks, a number of approaches have been proposed, and largely there are three main branches. First, list-based approaches filter out phishing emails using blacklist or whitelist. So blacklist contains malicious contents, and whitelist contains genuine contents. And the heuristic-based approaches find anomalous patterns by predefined rules. And researchers define the rules based on the previous phishing attacks. And the machine learning methods, which is the main trend in these days, calculate occurrences of features or the combinations of features in a statistical way. And the machine learning, the algorithms learn the features from the given data. So the state-of-the-art systems with different aspects showed some promising results and prevented a little bit of phishing attacks. However, they still vulnerable to new type of phishing attacks, unseen phishing scams. And the main reason is that phishers frequently change their phishing contents, and the recent trend of phishing attacks is that phishers more exploit human weak points rather than technical vulnerabilities. So superficial clues have limitations to find the subtle difference between the previous phishing attacks and unseen phishing scams. So here I propose to analyze phishing contents semantically instead of comparing superficial or visual characteristics of phishing attacks. So to analyze phishing contents and legitimate emails in a semantic way, I designed a phishing ontology. And the purpose includes the conceptualization by word sense disambiguation and knowledge representation of semantic relations. And the knowledge representation is a machine and human readable format so that we can verify whether it is correct or not. So in this research, I used two data sets. So for phishing emails, I used phishing emails from Anti-Phishing Working Group. Anti-Phishing Working Group is an organization where people fight against phishing attacks and they collect phishing emails from online users around the world. And for legitimate emails, I used two different legitimate emails. First one is unknown emails, which is pretty common legitimate emails in the research domain. And the other one is the politician Jack wishes emails. I first pre-processed the data sets, and the pre-processing includes the remove duplicates and remove garbage text such as the tags or the typos or things like that. And then I got 38,688 phishing emails. And since the legitimate emails, the size of legitimate emails was much greater than the phishing size, I selected the same size of legitimate emails as phishing emails. And using these data sets, I built phishing ontology. So to build phishing ontology, I use ontological semantic technology, which is an ontological semantics-based system that handles the semantic processing for natural languages. So the ontological semantic technology, OST, consists of two main components, ontology and the lexicon. And ontology is a language-independent concepts and their semantic relations. And the lexicon is a set of words of a particular natural language. In this research, I only use English lexicon. So, since the ontology is built by the human efforts, I had to limit the scope of the words to insert the words into the ontology. So so here my main interest was to disambiguate the word meanings, the meanings of words that frequently appear in both phishing and legitimate. So the superficial feature-based classifiers wouldn't recognize the difference between the two because they look the same. But I was interested in the difference, the meaning of words. So I first ranked the verbs in a text based on the TF-IDF, and I selected 61 number of verbs that frequently appear in both legitimate and phishing. And I defined the word senses based on the verb's dependence, because the verb's meaning is determined by their dependence. The arguments were dependent, were components in a sentence. So the OST generates text meaning representation for a sentence as an output. So after it processes a sentence, it gives a graph-based representation which consists of concepts and their properties. Here the concept is the word senses, and the properties is the relations of concepts. OST finds the best TMR among the possible TMRs based on the weights of TMR, based on the graphs, which are measured by the total distance in the OST graph. So here we have a sentence. You must update your password. Here the verb update has two arguments, you and password. And the verb update and its two arguments, you and password, are given to the TMR processor. So it's a TMR example for a phishing sentence. So you must update your password. The update has several meanings. And here, in the TMR, the green nose indicates lexing words, and blue nose indicates concepts, and the edges are properties. So here, the verb update has two arguments, you and password, and the concept of you is human, and the concept of password is a private information. So it connects to the verb update is connected to these two concepts. After that, you find the concept of word update is update information. Here we have a legitimate sentence. I will update you with any revisions as they occur. The verb update has two arguments, I and you, and both are human concepts. Since they are the object of the verb update is you, which is a human, so in this case, the sense of the verb update becomes informed instead of update information. So in the experiment, I used the word concept to train machine learning classifiers. So in this experiment, I used the three machine learning algorithms: logistic regression, support vector machine, and random forest. And F1, I used F1 to measure the classifier's performance. In the first experiment, I created the baseline and using three different feature sets: email feature set, lexeme feature set, and concept feature set. If you look at the figure here, we have an email, and the classifier trained on the email feature set, it will use all of these features to be trained. And in the email, if any sentence has one of those selected verbs, the processor extracts the sentences, and then it extracts the verbs and their arguments. So here we have two sentences: check your recent activity and please update your information promptly. So here we extracted lexemes, check your activity, update your information. And these four will become the features for lexeme-based classifiers. And the concepts are the corresponding concept of those lexemes. So here we have verify, private information, update information, private information. And these will become the features for concept-based classifiers. So I tested them using tenfold cross-validation, and here we can see email-based classifier classification show the highest score. So which means that the classification task take more information than just verbs and their arguments. And the concepts show the lowest performance, even though the gap between lexeme-based and concept-based classifiers' performance was not significant. So for the next experiment, I first wanted to see how the lexemes were conceptualized. So these are one of the top features used to train the classifiers. Here you can see the word U and V. They were conceptualized the concept human, and the word account, password, username were mapped to the concept password information. And receive, send, give, they were mapped to the concept relay information. Of course, they can be mapped to a different concept depending on their arguments. So total 2,460 lexemes were mapped to 525 concepts. And I thought lexemes were only useful if they exist in new phishing emails. On the other hand, the concepts exist in a higher level, so it can handle more variants. So to test that, again, the features frequently change their phishing contents. So a word can be easily replaced with their synonyms. Here what I mean by synonyms is not the dictionary synonym. I mean, if they belong to the same concept, then here I call them synonyms. So, for instance, ID, username, password, passcode, as a social security number, PIN, they are different words, but they can belong to the same concept, private information. So I checked whether synonyms would decrease the performance of classification. So I reran the lexeme-based and concept-based models on data with synonym substitution. Here's an example. We have two sentences. Here, the original lexemes were check your activity, update your information, and they were replaced with their synonyms. So instead of the verb check, it was replaced with the verb verify, and the verb update was replaced with the verb change. And instead of using the your activity, I replaced the word with the profile. And I use different size of feature sets, different scopes of feature set. So here you can see the concept-based model shows consistent results. However, the lexeme-based models performance dramatically decrease as we change words more and more. Since these results were based on the synthetic data set, I wanted to test in a real-world data set. So in the experiment 3, I used different test set using the trained model in experiment 1. So here, the concept-based models show the higher performance than the lexeme-based models. And I wanted to test the effectiveness of the concept in the whole emails. So I replaced the words in the email text with their concept. So we have an original email. Here, I replaced the word, considered words with their concept. The concept substitution a little bit helped the classifier's performance, even though the effectiveness was not significant. So, but their improvement was consistent from the lexeme-based to the email-based. But still, in the email feature set, I still need to cover more words rather than just verbs and their direct arguments. So conceptualization proved to be useful in the machine's classification ability between legitimate and phishing. And the lexical feature-based models showed limitations when they face with unseen data. So the future work will include to expand the scope of conceptualization, possibly from a sentence boundary to the paragraph boundary and to the text, the whole email boundary. Thanks.
Thank you. Any questions?
So how much of manual work is involved in selecting these words and mapping them to the correct ontology? And if you would use a different type of data sets to test from a different domain, not from a company or from a politician, how much would you have to redo?
It depends. It depends. Of course, of course, it's much time-consuming than automatically process data by machines. But for now, the ontology is constructed by human efforts. So for this work, I spent probably 2 months or so to insert concept, to find the concept and their relations. But it took me a long time because I was learning at the same time about the philosophical theory of ontology. So once you get familiar with finding concepts and defining lexemes, then the time didn't take that long.
So did you store this data somewhere
Yeah.
in your system or like in the
Yeah, you can access to that online. It's developed on the web-based, so we can check.
But I think you use a couple of data sets, right?
Yeah.
And I believe they all having different formats.
Yeah.
You need to come up with some one format that can handle all the data.
Yeah. Yeah. So yeah, they are all emails, but they have different formats. So when I was pre-processing the data, I extracted the text portion of the emails, and then after extracting the text parts, and then I transform them into the processable format for PMR processor.
Any other questions here?
So in the data set and your proposal method, can we make generation, phishing text generation for part pooling your classification method? It seems to be a cat and mouse game, I think. Once you propose from a classifier, classifying based on a real normal figures. With such a data, can we make some text generation of phishing with your data set and proposal method?
So you mean, can we use this approach to make a fake phishing? Yeah, it's possible. I mean, in the phishing ontology, we have the synonyms of words that frequently appear in phishing emails. So using those synonyms, we can create fake phishing emails. Yeah, I mean, it can be useful to for phishing campaigns to educate users.
By comparing the running data, the image video, the running the ticket is not high impact. It's not cost of purpose, I think. The once you the data is available, the ticket is data is available for people that are easily implemented.
Yeah. So everything is implemented on the web page. So if anyone wants to access to this research, then they can access to it. Yeah. Is that what you mean?
Yeah.
Okay.
Any other questions? Let's thank the speaker and this